Hello and welcome to the Chemistry Made Simple podcast. I'm your host, Matthew Macario, and this is the podcast where you get chemistry confident and we take you from point A to grade A. Hello and welcome back. I hope you've had a good week since the last episode, and I hope that you're ready to move on to a slightly new topic. So in the most recent episodes, we've talked about all things thermodynamics. We've talked about definitions of enthalpy changes, and we've talked about entropy, Gibbs free energy, and how to predict whether a chemical reaction will proceed or not. Now we're going to move on to kinetics. And in kinetics, we're going to start today by looking at the rate of chemical reactions. And today we're going to define what we mean by that. So we'll talk about what is a reaction rate. We'll talk about when you can measure a reaction rate. What does the rate at any moment mean? Is the rate the same throughout a reaction, throughout an experiment? Let's start by defining what is a reaction rate. Well, by rate, of course, we mean at what speed does a reaction take place? And how we measure that is by the change in concentration of one of the reactants or one of the products. So the change in concentration of one of the reactants depleting in concentration, or the rate of increase in concentration of one of the products. Okay, so that's a few things that the rate of reaction can be expressed as. So it's really important when we express the rate of reaction that we are expressing it relative to reactant A or B or product C or D, for example, because the rate might be expressed differently for some of those depending on the stoichiometry of the reaction. Okay, so if we're doing this experimentally or we have some experimental results that we need to work out the reaction rate, the thing to do is to put that data onto a graph, and that graph will have time along the x-axis and concentration of whichever of the reactants or products we've chosen on the y-axis. If that's a reactant, the line that we'll end up plotting starts at a higher concentration and reduces in concentration through that period that the reaction takes place. If we're plotting for a product, the concentration will start low, potentially at zero if we're starting with none of the product already there, and that line will increase, showing an increase in concentration of that product throughout the reaction period. Okay, so now we have that information. How do we work out the rate? Well, in most cases, those lines that we've plotted are not going to be straight lines. That means the reaction rate is not constant throughout that period, and that's to be expected. So when we're calculating a reaction rate, we need to also refer to what instant during the reaction that reaction rate relates to. And if we're going to do this from the graph that we've plotted, we would find that time across the x-axis and project upwards to the line we've plotted to find the gradient at that point. And then to measure that gradient, draw a straight line showing the gradient at that point in time. We can then determine from that straight line that we've drawn the change in concentration and time over that section of graph. And the reaction rate at that instant will be that concentration change divided by that time difference that we've marked for that gradient. So it's important for us to remember as well, this is the reaction rate related to that reactant or that product at that moment in time, at that many seconds or minutes or whatever into the reaction. And also, if we were to look at a different time within the reaction period and measure the gradient there, we would find a different gradient in it. That means a different reaction rate. Likewise, if we were to look at a different reactant or product and plot that concentration and measure it at that same time we were looking at before, if the stoichiometry is different, we will find a different rate of change in concentration. So the rate will appear to be different related to that reactant or product. Okay, so what have we talked about today? We've talked about rate of reaction being the rate of change of concentration of one of the reactants or products within a reaction. We've also said that that reaction rate is not consistent throughout the reaction, and that actually when we express a reaction rate, we're talking about an instant in the reaction. Hence, we would plot that data and mark the gradient at the time that we want to know what the reaction rate is at that time. In our next episode, we're going to be talking about a mathematical expression of the rate of reaction. We're going to talk about the rate constant, and we're going to talk about something called order of reaction as well. If you have any questions about what we've talked about today, then please do get in touch. And I'm very happy to take your questions on that. The best place is Instagram. I'm at Chemistry Made Simple. You can also contact my email, matthew@chemistrymadesimple.net. Until that next episode, do look after yourself and goodbye. Thank you for listening to this episode. I hope you found it useful, and if you have had value from it, do consider visiting our Patreon community at patreon.com/chemistrymadesimple, where you'll be able to ask deeper questions about this topic and get more support for your studies too. So I look forward to speaking to you again in the next episode, and until then, do look after yourself and goodbye.